All right, so I'm going to try to pull the miracle of discussing how to artificially manipulate memories in 4 minutes. So that's what my lab focuses on. We focus on the neural underpinnings of memory. We want to figure out what are the cells in the brain, for instance, that process a particular memory, and then can we turn those brain cells on and off and thereby either drive or inactivate particular memories. So we work in rodents. We developed a technique a few years ago on trying to identify brain cells that process one particular memory. And we find the brain cells that we think hold on to, in this case, a fear memory, for instance. And then we ask, can we, one, visualize it? What you're looking at here are blue brain cells. We trick them to glow blue in an area that we know is important for memory, the hippocampus. And then we ask, can we go in and genetically engineer them to respond to light by playing this whole optogenetics game, and then going in and shooting light into the brain and activating those brain cells. And then more recently, I joined BU in July. I went here for undergrad also. And we were asking now, can we do this in the context of animal models of psychiatric disorders? So to give you a glimpse into the kind of work that we do, I just want to briefly actually go over one bit of data that I'm particularly excited about. Okay, so the way this works is we developed a way of, again, capturing these brain cells that process one memory, in this case, a positive memory, which if you're a mouse, if you're a male mouse especially, being exposed to female mice is particularly rewarding. It's nature's most potent social reward. So what we can do is expose male mice to female mice, for instance, and then find the brain cells that hold on to this positive experience, and again, engineer those brain cells to respond to light. So next, we put these animals in what we'll just call environment B, and we give the males, in this case, mild foot shocks. We give them a fear memory. So we do this as an attempt to model, for instance, certain components of PTSD and traumatic experiences. So now, normally the next day when you put the animals back in the environment where they were shocked, they will go into a corner and freeze, right? It's this evolutionarily conserved response where they freeze in place because they don't want to be detected by a potential predator. As an undergrad at BU, I would run into an ex-girlfriend, for instance, walking down Comm Ave, and you immediately get that freezing response. Also, humans do the same thing. So now we're asking in animals, what happens when we go in and we put them in this environment, they freeze, but what happens if we go in and optogenetically activate these hippocampal cells that process a positive memory? So we go in, we activate these brain cells, and what you can see here is this is separated into 10 minutes, this is separated into 5-minute blocks. So there's an EYFP control group, there's a channel rhodopsin experimental group. You'll see them the first 10 minutes, these animals show intact freezing levels. Whereas when we turn the light on and go in and activate these brain cells that process a positive memory, we see this modest decrease in freezing responses, for instance. Now, we chose this time frame on purpose because one of the things that we've learned is that memory is modifiable and it's susceptible to modification after a certain period of time. So we asked, by activating these positive memories during this period of time where we think a memory is modifiable, can we go in and permanently dampen that fear response? So finally, what we do is we can put the animals back, for instance, in that environment yet again. And what you see is that even in the first 5 minutes, they already showed decreased freezing responses a day later, arguing that we can go in and by activating positive memories, we can at least up to 24 hours suppress the return of fear. And then other projects in the lab, of course, focus on, rather than activating positive memories, for instance, can we inactivate the cells that we think process a negative memory and do so in animal models of depression and anxiety and PTSD? Thank you.